right, so we got old FRQ test. This was the COVID year. So we made the test short because nobody could do any work during the COVID year. We had the worst results ever, and it wasn't even close. Like it was so bad. But thankfully we're out of that. And then also when I made this test, the situation came out in the news where some lab was lying about their results, and they've given it was much worse than this. Like this one makes it kind of iffy, but that's where this problem was begot. It is not a political statement. It was just something that was on the news, and I found to be hilarious. But the lab and the thing, they were like 99.7% of their tests were positive. And it turned out they weren't even testing it. They were just saying everybody was positive. And I just found that to be freaking hilarious that they got busted on that one. So then I made this question. So it says the lab is concerned about the number of positive tests it's found in the last 2 weeks. 23% of all tests for COVID-19 have come back with a positive result. Totally made that up. In the last 2 weeks, 45 out of 156 were positive. All right, so just for a little point of reference here, like, well, okay, so what was that, more or less? Because I can't do that math in my head. So they had 28.8% instead of 23%. Good, decent size sample. Is it enough? We'll find out. Okay, well, I mean, you can look down and see that it is. But anyhow, so this is a proportions problem. It was how many successes out of the total number, 45 out of 156. So I'm going to start with my null. P is equal to 0.23 because that's what they claim the national average to be. And then P is that this lab is getting more than it's supposed to. And P is the true population proportion of positive COVID-19 tests from this lab. Not all labs, from this lab. Not from the 2 weeks. All of them. Also, okay, it doesn't say anything about a random selection, but I see I've covered that. I believe that was a mistake that I covered with something that we might run into. So maybe it was on purpose. I doubt it. Okay, so here we go. So this one, it's a one sample Z-test for P. Simple enough. We're going to assume that this was a random selection. Now, it does say it's all the 2 weeks. I ain't loving it. I am not loving that. I am not loving that at all. So we need to assume that 156 was a random sample. And we need to assume that there's at least 1,560 COVID tests from this lab. Or again, that there's definitely some issues with that. And then we get our expected counts. There's nothing too fancy about that. And then calculator. So stat test 5. And this one, P naught was 0.23. And we had 45. How about that? I used 45 on two different numbers. That's weird. And we're trying to show greater than. And remember, this arrow and this arrow go in the same direction. And there's my Z and P value. And look at that P value. It's close to 5%, but it is less than 5%. 1 in 4 is 1 out of 25. I mean, 4% is 1 out of 25. 5% is 1 out of 20. That's actually quite a bit lower. It doesn't seem like it is, but when you think about 1 out of 25 versus 1 out of 20, that's actually a pretty good difference. So the P value is less than alpha. We reject null. There is evidence that the lab has more positive tests than expected. And and then because they're trying to get federal funding or some whatever it was. Thankfully, that's a long time ago now, and we don't have to worry about this anymore. So interpret the p-value. If in fact the null is true, that the true population proportion of tests from this lab is equal to 23%, the probability that we obtained the results that they got, or one that is even crazier, that's even worse. In this case would be even higher, right? Because they had too many positive tests. So the probability we got that one or more positive tests is only 4% by random numbers. That's what random numbers in a simulation would result in. If they just did pure random digits, this circumstance would happen 4% of the time. That's not good enough. So what do we say? We say no to the null, and it's got to be something. It can't be, well, it can be, but we're going to suggest that it's not chance variation due to random assignment. It's something else. What's the something else? This lab is a bunch of dirty liars and cheating the system. All right, next. This one is about, I'm going to be honest with you, I just totally stole this problem. I wanted one where the context was weird and I just can't come up with stuff because I'm just not that smart. I did like how it gave us abbreviation here. This is one of the reasons why I stole this one, because when they give us abbreviation in the question, we're allowed to use said abbreviation in our write-up. All right. So this company has this cable, and their competition has a capacity of 3,000 pounds, and they think theirs is better than 3,000 pounds. So, and then if they can prove that, they can sell their cable for more than their competition, or drive their competition out of business, or steal their business, or whatever. So mu is that it's equal to 3,000, and then we're going to see if it's bigger. All right, and then we got alpha, the true population mean, MBS, for this type of cable that this company manufactures. And like, golly, that context is ugly. It is. It is. And the College Board will do that, and so will I. Excuse me. All right, one sample t-test for mu. That's not the greatest mu ever, but we'll just let that go. Assume a random sample of 32 cables. For this test, we assume there's at least 320 cables to select from. And 32 is greater than 30. God, I like that. Oh, yeah. Like that one better than the box plot. All right. And then the maths. So stat test 5, stat test 2. And this is the stats half of things. So we're saying 3,000. The average was 3,022.8, and the standard deviation was 47.2. And sample size was 32, and we're trying to show greater than, so I don't have to mess with that one. And voila, T 2.7, the p-value is less than 1, and degrees of freedom. Oh, don't forget about your degrees of freedom. Only on a means problem. Don't put it on proportions, and don't forget it on the means. The p-value is less than alpha. We reject null. There is convincing evidence that our cable is stronger than our competition. Describe a type 1 and type 2, and which one's more serious. So, type 1 favors the alternate. We say that our cable is stronger when in fact it isn't. Okay, let's think about that. A cable is used to hold heavy things in place, and if we say it's a certain strength and it's not, that ain't gonna be good for somebody, right? Whether if somebody gets hurt or whether somebody has all their crap damaged and then they sue this company for everything they own, whatever, that ain't good. Okay, then the other one is we suggest that the cables are not strong enough when in fact they are, or stronger than our competitions when they are. That one's a lost opportunity. So we can't advertise that our cables, we're not going to be able to, at least. We're going to miss the opportunity to brag about ours being better. So we could outsell our competition, maybe put our competition out of business, maybe, I don't know, sell enough cable to get a trip to Disney for your kids, whatever. You got to come up with something. And then which one's worse? Well, the first one is people's lives are at danger, or maybe it doesn't have to be lives at danger, but these cables start breaking and then they're like, I ain't buying cables from this company no more. That's how that works. You get inferior products. You don't continue to go back and buy. Well, you shouldn't. We do, but we shouldn't do that. But there you go. I would suggest that the type 1 is significantly worse than the type 2. Remember, if you compare the consequences, we'll take it.